in Oswego right now, it is 13 degrees outside. 13, that's right, 13. And would you look at that, it is snowing out. We have a band, we have a little cluster of lake effect snow showers moving through. Visibility is a little bit, it's kind of poor. These are dendrites, yeah, these are dendritic snow showers. So I'm gonna open the door just for a moment because it is very cold outside. I mean, it's like very extremely cold out. Like, so I'm just gonna, it's 13. Yep, there they are. They're the dendrites. And yeah, they're clustered because there's some humidity in the clouds. Clouds are very low. They're about 2,000 feet up. And you can see, if you look close at some of the snow streaks falling from the clouds. Yeah, that's because of how cold it is outside. Air temperatures are only 13 degrees. This is well below normal. This is even colder than the nighttime average temperatures for this time of year. So yeah, it's cold out, and this is the middle of the day. It's 13. I said the low tonight is going to drop to the single digits. And that's despite an onshore wind. And very often in Oswego, you get what is called a land breeze, where the wind blows off the land into Lake Ontario because the lake is warmer. So you get cold air blowing off the land. And this happens normally during the day, also at night, but I'm not noticing a southeast wind. I'm noticing a north wind coming in, an onshore wind, even at the surface. But the predominant wind flow is offshore, with an onshore wind during the summer. You could call it a sea breeze, but here we call it a lake breeze. Doesn't really form thunderstorms. It's not like you get in Florida where you get converging sea breeze boundaries forming thunderstorms. Rare occasions you can form some clouds from them, considering Lake Ontario is very big. But this is happening because Lake Ontario, especially the middle of the lake, it's still warm. It's in the mid to upper 30s, with only the near shore being frozen. So yes, there is definitely a lot of convection coming off the lake, a lot of moisture, and forming these snow shower clouds. Even though the clouds are very thin, they're not very thick clouds, there's enough moisture in the atmosphere because of how cold it is that even with barely any clouds, you're getting snow coming out of them. I looked out the window and saw snow flurries about an hour ago. And even though there's barely any clouds overhead, and the clouds did not look like they were snow bearing or precip bearing for that matter. But sure enough, we're getting snow with temperatures at 13. This wasn't really a true Arctic front. This was actually more of a low pressure system. And I'm looking for next Sunday. The models are showing a major snowstorm for Oswego, possibly 1 to 2 feet of snow from a storm system with lake effect behind it. There you go. It is 13 degrees outside right now, and it's snowing. Yeah, it's lake effect. So, thank you. I'm coming in. Sorry, someone stole my wallet yesterday.
Oh, damn.
Yeah, I was on the bus and someone stole my wallet right off my seat, and I didn't even notice. Have a good day. So I'm gonna... By Jin Jining and Harp? No. This is just normal. This is pretty normal. I mean, the all-time record low in Oswego is negative 16, and that happened a long time ago. It's actually a little bit warmer by the lake because you're getting some of that warmer air coming off the lake. So it's 13 in Oswego, but the further you go away from the lake, it gets colder. This is normal weather. This happens a couple times in winter. You get such cold blasts here in Oswego. Yeah, it's 13 Fahrenheit now. At night, it's going to be 6. But areas further away from the lake are going to get sub-zero, especially when you get clear skies and natural evaporational cooling. 5-6 degrees aren't unheard of. In fact, the coldest temperature I've ever seen in my life happened here in Oswego, -9, 2 years ago. This was courtesy of an Arctic front, though. This was despite an onshore wind coming off of Lake Ontario, we got down to -9. Syracuse, I believe, got down to -13. Wow. For just to let you know, the HARP project has been shut down years ago. It's no longer being active. And even though HARP is like it affects the upper atmosphere, it only affects the mesosphere. It does not cause the jet stream does not cause the atmosphere to buckle. It doesn't bring heat to the atmosphere. It's simply charged particles. Charged particles do not heat up the atmosphere because this is electric. This is not like microwave radiation. And really, they just monitor. HARP is called the High Altitude Auroral Research Program. So what they do is they listen to the auroras. They don't cause auroras, nor do they affect the weather. HARP is basically a listening device. No, HARP is not worldwide. HARP is only in Alaska. And as humans, eventually, we will be able to moderate the weather, to benefit humanity. That's actually a good thing. You're having a hurricane coming toward the coast, you're not going to send some beam to destroy the hurricane. No, that's not how it's going to work. You're going to bombard the hurricane with a polyabsorber, a chemical that's going to absorb all the moisture and sap the energy right out of the hurricane. That's how weather modification is going to work, but it hasn't been put into practice. It's theoretically possible, but humanity is no better at controlling the weather compared to 50 years ago. In fact, we have not advanced in terms of controlling weather. What we have advanced in is changing the climate, which affects the weather with carbon dioxide, methane, natural human activity. Those quote unquote chemtrails you see is because in ahead of a storm system, your upper atmosphere is moist. Your upper atmosphere, right around where planes fly, 30, 40,000 feet, a couple days before it rains, you'll see cirrus clouds. And you'll see lingering contrails, right? Instead of them disappearing, contrails, normally you see them and then they vanish almost immediately. That means the upper atmosphere is dry. This happens particularly on a cold day with no clouds, especially in the winter. If the atmosphere is wet, like you're having an approaching storm system. So high clouds are overspreading your environment, or it's moist, the contrail will linger. And especially if there's high winds, they will spread out. I've noticed this many, many times. In fact, I've tracked those lingering contrails. They're all coming from airliners. All they're using is jet grade A fuel. And that's soot, the same stuff you get in your fireplace. The particulates from the jet exhaust, you get hot jet exhaust coming out of the tailpipe into an environment that's 40, 50 degrees below zero. Imagine a temperature difference of 150 degrees Fahrenheit from, you're getting a jet exhaust of 500 degrees, right? Coming into an environment that's -150, -60. That's just almost 600 degree temperature difference. And all of a sudden, there's condensation, and clouds form around the condensation nuclei, that is the soot particles. And in a dry environment, the contrails would last maybe 20, 30 seconds or even less, and they would disappear. In a moist environment, they would not only linger, but they would spread out. They would immediately turn into ice crystals. They would crystallize. And because they're ice crystals, it's harder for them to vanish. So they linger, and then they spread out and form this thin veil. Contrails are actually changing the climate. And a lot of climate scientists are claiming, this is true by the way, that carbon emissions from aircraft have less of an impact on the environment compared to contrails because of their nighttime, what they do at night. So during the day, clouds have a reflective property. They reflect solar radiation back into space. So during the day, it has mostly a cooling effect. But at night, when the sun sets, just like regular clouds, it makes it harder for solar radiation, for infrared radiation to escape into space. This traps the heat. This traps the infrared radiation, which heats up the planet. Contrails are actually, they said on a single day, contrails are heating up the planet more than all of aviation's carbon emissions have over the past 100 years. So that's how much of an impact those contrails have. They're not chemicals. They're not chemtrails that are making us sick. No, that is not true. But they are causing climate change, making it worse. So if you don't want to contribute to that, the real problem is those nighttime flights. They're the big problems. Daytime flights, they have a very slight cooling effect, but the warming effect at night is magnified tenfold. Think of Venus. Venus is covered in clouds. 99% of solar radiation is reflected, but Venus has a night atmosphere 90 times the atmospheric pressure at the surface, almost all carbon dioxide. Yet Venus, despite having that very thick cloud cover at the surface, is over 700 degrees Fahrenheit. Why? Because of all the carbon dioxide trapping in that tiny little bit of heat that comes in, the tiny little bit of solar radiation that comes in, it's trapped, can't escape. Therefore, you have temperatures of over 700 degrees. If Venus had an atmosphere like Earth, one atmosphere pressure with the same amount of carbon dioxide we would have, Venus would be not a temperate, but would be a tropical planet with similar conditions to that of South Florida, Mexico, the tropics. You would have an average surface temperature of 80 to 90 degrees Fahrenheit across the planet. The poles would be similar to a climate of, northern United States, with the tropics being more like a climate you would find perhaps, very hot, temperatures of 100 degrees, 120 degrees with high humidity, or maybe deserts. But Venus would be habitable, especially in the mid and upper latitudes. Venus would be habitable if it had an atmospheric pressure and composition similar to Earth. But the reason for why it does not have an atmosphere, does not have a magnetic field, it boils down to its rotation. Venus is tidally locked. It does not rotate. It does not rotate on its axis. It's tidally locked. Most likely because of its how close it is to the sun, but it could have been a big object hit Venus and prevented it from attaining a spin. But most likely it is because of its proximity to the sun with its size. If it was smaller, Venus was even smaller, it might have been able to rotate. For instance, I believe Mercury goes around the sun so fast that a year on Mercury is only several Earth days, while on Venus, an Earth year is several months on Earth. So it's still in the habitable zone. Technically, Venus could have been a habitable planet. Mars is also in the habitable zone. Earth is smack dab in the middle. The reason for our habitability is because our atmosphere is not too thin like Mars and not too thick like Venus. If our atmosphere was similar to Venus, 90 atmospheres of pressure, we would probably have a surface temperature of 400 to 500 degrees Fahrenheit with a similar atmosphere to Venus, composition, pressure. If Mars had a similar atmosphere, they would have an average surface temperature of 200 to 200 degrees Fahrenheit. Still too hot for life. And the atmosphere would probably kill anybody. Venus will not have any life. I mean, if it does, it's higher up in the atmosphere. There is a place in the Venusian atmosphere where there's one atmosphere of pressure with temperatures comparable to Earth, with temperatures around 80 to 90 degrees Fahrenheit. But the problem is it's carbon dioxide and hydrochloric acid. Not suitable for life as we know it, but you never know. There could be some microbes that consume hydrochloric acid or carbon dioxide. So it's possible that higher up in Venus's atmosphere, it's Earth-like in terms of pressure and temperature, but not in terms of atmospheric composition. Like you've seen Star Wars, you've seen, Bespin, Cloud City, Bespin 9, Cloud City. There are ideas that to build habitable areas in that part of Venus's atmosphere. Problem is you can't breathe that atmosphere, so you would have to have oxygen supplies on the ship, and they would utilize the surface, like you would have breathing apparatus, and so you wouldn't have to wear spacesuits because the pressure is Earth-like. So the only problem is the breathability of that part of the atmosphere, but not pressure. So no spacesuits would be necessary. You can't just have them hover. So most likely, because Venus does have a rocky surface, you would attach a polymer of, probably some sort of metal, likely steel, which has a very high melting point, and attach it to Venus's surface, which is 600 to 700 degrees, but use a type of polymer to reinforce it with graphene, which is extremely, extremely tough, very tough. It's not like it's strong as in terms of it could hurt you, but very tough under pressure. It has a density, a strength, a tensile strength, 20 times stronger than diamond, 40 times stronger than steel. So that, wrapped around or inside embedded in steel, could help it withstand the 90 atmospheres of pressure and allow the cities to be there, basically hovering cities, but they're not hovering, they're anchored to the Venus's surface at an altitude of 40 to 50 kilometers above the surface. Yeah. Graphene? They're not. Graphene is. It's literally rocks. Graphene is rock. It's what you find in your pencils. It's graphite. It's coal. It's a more advanced form of coal after you put it under pressure for a few million years before it becomes diamond. No, graphene doesn't cool down the atmosphere. Graphene is what we can use for electricity, energy storage, protective shields on vehicles, bulletproof vests, for instance. It's very good at redistributing energy. So a bulletproof vest, if a soldier is wearing a vest made of graphene, they would likely not even be hurt by the bullet because the energy would be redistributed throughout the whole body. Nanographene has uses in terms of holograms, but that's only ideas. Nanographene has not been developed yet. It should be, it would be great for, nano. Here's the thing. I'm against nanotechnology personally. I fear that using if nanotechnology, nanobots can take a mind of their own, it's too dangerous. But nanotechnology, when I say technology, I don't mean small particles of polymers. No, I mean micro machines. That should never ever be developed. That's just unacceptable. But using small nanotechnology that's not smart, that's not machine, has practical purposes. For instance, there's sweaters of nanoparticles, combined to make new polymers, for instance. Using graphene as to create almost an invisible holograms. Imagine a hologram that is transparent. You can't see it because it's so thin. Imagine an invisible TV screen, right? That's what we're talking about. How is it the devil? Nanotechnology is not the devil. Look. I know look, I understand that you fear emerging technologies. People have always feared change. It's natural to fear change. But change can be good or bad. Fear of the unknown is what causes, you know, fear, it's basically fear of the unknown. You don't know if it's going to be good or bad, so why should you trust it? As I've heard of Project Bluebeam, to make humanity think there's an alien invasion to create a one world government. I am well aware of Project Bluebeam, and that is one of Alex's Jones' favorite brainchilds. It was basically him just spouting out all this nonsense. Let me explain something about Project Bluebeam. It's basically, the idea of it is that the governments are all going to create a one world government. For one thing, that ain't going to happen. It's at the current rate that our technology is advancing, it would still take at least 100, 200 years before this happens, if it theoretically is even possible. As humanity becomes more united, the chance of trying to force humanity to unite through something like Project Bluebeam becomes just less feasible. To try to control humanity through fear, like the way China does, Russia, is not feasible. Wasting all this money on security, it's just not feasible. Look, Neuralink. Okay, look. If you continue to believe in conspiracy theories like this, you risk going into something called a psychotic break. You gotta stop overthinking things and just enjoy life. Look, if you're religious, continue dedicating your life to God. But listen, you are putting your own sanity at risk. This is not what God wanted. He did not want you to be paranoid over every little thing. This is not what God wants. This is not what Jesus wants, You need to literally enjoy your life and look at all the good things that's happening in the world. But you're only focusing on the bad and bad things that haven't even happened yet. I understand, if you worry about 1,000,000,001 things, there's chances are you're going to be right about one of them, but try not to let, fear of the future, fear of the unknown dictate your life, man. Robert, of course you're not an NPC. No one is an NPC. No one is everyone is independent. NPCs are all predetermined. They have certain sets of behaviors. I'm not an NPC, neither are you. No one is an NPC. Look, AI is an NPC. AI is fake. But listen, Robert, stop stop allowing fear to control your life and just enjoy it, all right? I grew up in a very toxic environment, had PTSD. I weighed 300 pounds because of high cortisol levels, because I allowed fear to rule my whole life. And recently I came out of that. Robert, just enjoy your life and stop worrying about every little thing. Stop making it your whole identity. I don't know who you are, what you do with your life, but okay, being ready is one thing, but to be paranoid about it is another. There is a difference between preparing, hoping for the best and preparing for the worst, and just fear-mongering, all right? There's a difference between those two. Just enjoy your life, all right? I'm ending the live stream. I will. Thank you.